Hello friends, my presentation topic is ARM GPIO Programming. So I will give you some brief information about ARM GPIO Programming. GPIO stands for General Purpose Input Output. GPIO pins of a microcontroller are the first thing we need to learn before starting its embedded programming, as input output pins are the only way to interface with the microcontroller. GPIO pins can be used for driving loads, reading digital and analog signals, controlling external components, generating triggers for external devices, etc. GPIO is used to interact with the basic peripherals like LEDs, switches, and other components. It can also be used for more complex components like text and graphic LCDs. In order to get started with the GPIO, you need to understand the 4 registers that control it: IO DIR, IO set, IO CLR, IO pin. Let's discuss IO DIR register. It is a GPIO port direction control register and is used to set the direction. Either the port work as an input or either the port work as an output. When a bit in this register is set to 0, the corresponding pin in the microcontroller is configured as an input. Similarly, when a bit is set as a 1, the corresponding pin is configured as an output. The syntax for register IOX DIR, where X is the port number. If we want to use port 0, then we have to write IO0 DIR, and if we want to use port 1, then we have to write IO1 DIR. Let's discuss IO set register. It is a GPIO port output set register and can be used to set the value of a GPIO pin that is configured as an output to logic 1 or logic high. When a bit in IO set register is set to 1, the corresponding pin is set to logic 1. Setting a bit 0 in this register has no effect on the pin. The syntax for this register is IOX set, where X is the port number. If we want to use port 0, then we have to write IO0 set, and if we want to use port 1, then we have to write IO1 set. Let's discuss IOCLR register. It is a GPIO port output clear register and can be used to set the value of a GPIO pin that is configured as output to logic 0. When a bit in IOCLR register is set to 1, the corresponding pin in the respective port is set to logic 0 and at the same time clears the corresponding bit in the IO set register. Setting 0 in the IOCLR has no effect on the pin. The syntax for this register is IOXCLR, where X is the port number. If we want to use port 0, then we have to write IOCLR, and if we want to use port 1, then we have to write IO1CLR. Let's discuss IO pins register. It is a GPIO port pin value register and can be used to read or write values directly to the pin. The status of the pins that are configured as a GPIO can always be read from this register, irrespective of the direction set on the pin, input or output. That are the directions. The syntax for this register is IOX pin, where X is the port number, IO0 pin for port 0 and IO1 pin for port 1. Now we discuss some method. Method number 1, IO0 DIR equal to 1. This is the direct assignment method where the binary value 1 is set directly on the pin. All the other pins are set to 0. This method should be avoided as the value is directly being assigned in the register, and while P0.3 is assigned as a 1. All the other pins are forced to be assigned 0. It means it set the port 0 and its third number pin as an output. Method 2, IO0 DIR or equal to 0x00000008. In this method, The hexadecimal value of the resistor is assigned after ORing the resistor with itself. In this way, the other pins other than the desired pin are not affected. This method is useful if we want to assign many pins without affecting the other pins. Example of setting pin number 15 of port 0 as an output and drive the pin high. So for this we need to use two resistors, IODIR and IOSET. IODIR for the it's configured as an output and IOSET to send the high pulse. So first we have to define port 0 15 number pin as an output. So we have to write I0 dir or equal to 1 shift left by 15 times. Now pin number 15 is defined as an output. Now we have to send the high pulse logic 1. So we will write IO0 set or equal to 1 shift left by 15 times. Let's see the another example. In this example we are configuring port 0's 11 number pin as an output. Then we will send the high pulse and then we will send low logic level 0. So first we have to define its direction. So we will write IO0 dir or equal to 1 shift left by 11 times. So it will define port number 0's 11 number pin as an output. Now we will send the high pulse. So we will write IO0 set or equal to 1 shift left by 11 times. Make the output pin P0.11 as a high. IO0 CLR or equal to 1 shift left by 11 times. Make the output pin P0.11 as a low. Let's see the another example. In this example we are setting two pins, port number 07 number pin and 14 number pin. So first we define the direction IO0 dir or equal to 1 shift left by 7 times or 1 shift left by 14. So it will define port number 07 and 14 number pin as output. Now we will set pin number 7 and 14 as a logic high. So IO set or equal to 1 shift left by 7 times or 1 shift left by 14 times. The basic C program. Blink the LEDs repeatedly that are connected to port 1 pins of the MCU. Here the port 1 size is 32 bit. So we are connecting 32 LEDs with the port 1. First we define the integer delay. Then we will define our main program. First we define the directions. So we have to use port 1 as an output port. So we will write IO1 dir is equal to 0x FF. So it will configured as an output port. Now we are generating one infinite loop. In this loop we are setting the all pins and then we will reset it. Means first we send the logic 1 to all the pins and then after some delay we are sending logic 0. So when we are sending the logic 1, at that time LEDs will turn on, and then after some delay we are sending logic 0. So it will turn off all the LEDs. So to set the LEDs, IO1 set equal to 0x FF. So it will turn on all the LEDs of the port 1. Now we are generating some delay. For delay generating we are using for loop. So for loop will run 5 lakh times. After this delay, then it will comes to the IO1 CLR 0x FF. So logic 0. So it will turn off all the LEDs. Then after we are giving some delay and our main program is completed. So this is an infinite loop. So LEDs will turn on, then some delay, then it will turn off, then some delay, then will turn on. So this process is a continuous. These are the program explanation which I told in before slide. Thank you friends.